Okay, so your first blank on notes 4-9 is scatter plot. So a scatter plot is a graph with points plotted to show a possible relationship between two sets of data. All right, everybody got that? Okay, good. All right, so the next one, see how this one on the dots kind of go in an upward trend? When the dots go in an upward trend, that's called positive correlation. So that's your first one. Also, notice, Nick, will you act as Vanna White momentarily? See right there by the cart? Down below? Nope, lower. To the left. To the left. Off the smartboard. Off the smartboard. Down below. Down. Right there it is. Okay, he found it. Okay, see right there? It says positive correlation. So if you ever get stuck and need to remember what positive correlation is, there it is, right there on the poster for you. Okay? Next, if the points go in a downward trend, that will be negative correlation. Nick, will you go point at negative correlation for me up there so they can see where the poster is that describes negative correlation? Thank you, Nick. Excellent. All right, and then one more. Next, if your points have no pattern at all, then they have no correlation. So no correlation describes a graph that has no pattern. Thank you. All right. So on example 1, it says the table shows the number of species added to a list of endangered and threatened species in the United States during the given years. Graph a scatter plot using the given data. So we have calendar year and the species, and we're supposed to put it on a graph. So which of our two variables is acting like our x? Calendar year. So on your graph, label your x-axis the calendar year. I need to move mine over. I'm not going to have enough room. There we go. Huh? I know, it didn't show up very well on y'all's paper. I'm sorry about that. Okay, so then your y-axis would be what? Species, so we're going to label that. Okay, so for calendar year, what should we count by? Because here's our numbers. We go from 96 up through 2002.
We should count
By 1?
tens.
By tens? On the calendar year? Look, it goes 96, 97, 98, 99, 2000, 2001, 2002. So by ones, right? Okay, now, we don't want to count by ones from the year 0 to the year 1996, right? So we don't need any of those years. We don't need the 1800s or the 1700s or anything like that. So what we're going to do is make a little break in our graph. I know y'all have done that in biology before. Okay, so make a little break in your graph, and then you're going to start at the year 1996. Put that right there. Okay, and then we're going to do 97, 98, 99, 2000, 2001. Whoops, got off on my line there a little bit. And then 2002. Is that it? Where do we stop? I forgot. Stop at 2002, right? Okay, good. Then for our species, okay, the smallest number we need to graph is what? 9. And the largest number we need to graph is 91. So if we need to count from 9 to 91, what would be, count by tens? Okay, so we'll count by tens, whoops, on our y-axis. So 10, 20, 30, 40, 50, 60, 70, 80, just because it makes it easier for me, but you don't have to do that on yours. 90, just because I'm kind of far away and it's hard for me to see to get it that close. Okay, so in 1996, there were 91 endangered species, right? So in 1996, there were 91 endangered species, so I'm going to put a dot right there. And then in 1997, there were 79 endangered species. So let's see, 97, 79 would be about right there. And then in 98, there were 62 endangered species, right there. And in 99, there were 11 endangered species. 99 was a good year for endangered species. 2000, there were 39. And then 2001, there were 10. And then in 2002, there were 9. Okay, so we can't say that it decreases by 4 species each year. So there's not like a definite number that it decreases by. But as an overall trend, what happens? It is, as a trend, decreasing. So right here where it says what type of correlation exists between the calendar year and the number of species classified as endangered and threatened, what would you say that correlation is? Negative, because it's decreasing. Good, so that would be your answer for that one. Okay, example 2, there is no data. There's not a table, so we can't do example 2, so skip that one. I don't know, like I went to do it first period and I was like, there's nothing there to graph, so we'll just move on. Okay, so on example 3, it says identify the correlation you would expect to see between each pair of data sets and explain why. So on example 3, it says the number of empty seats in a classroom and the number of students seated in the class. So here's the way I do it. Y'all look at me real quick. Okay. As the number of empty seats in a classroom increases, I always let the first variable increase. What would happen to the number of students seated in the class? It would decrease, right? So if you have one variable increasing and one variable decreasing, that tells you it's a negative correlation. So here, the answer would be negative. Would the kids get bigger? No, the reason the empty seat is increasing is because the kids are decreasing. Oh, okay. Yeah, so the empty seats are increasing because the number of students are decreasing. Okay, so on example 4, it says the number of pets a person owns and the number of books that that person read last year. So as the number of pets a person owns increases, what happens to the number of books that they read last year? But there are some people who own pets that read lots of books, like crazy cat ladies, right? So is there a whole lot of correlation between the number of pets you own and the number of books you read? Probably not, right? So for that, we would say there is no correlation. Whoops. So no correlation. So if there are two things that are basically unrelated to each other, like my color hair and my color shirt are unrelated, okay? If it's two things that are unrelated, then it's no correlation. Okay, then on the last one, it says the monthly rainfall and the depth of water in a reservoir. So if the monthly rainfall increases, what would happen to the depth of water in the reservoir? It would increase, right? So if they're both increasing, then that would be a positive correlation. Okay, so then on the next one, it says choose the scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant, and explain. So on graph A, do you guys think that here's the time in days, and here's the height of the plant. So does that show what would happen to the height of the plant over a period of time in days? No? Why not? Because it's decreasing. The height of the plant is not going to decrease, right? So A is not it. Okay, what about B? B does show an increasing relationship, so is it B? I mean, if I were to look at these points, I would say, yeah, they're kind of going up at an upward trend. That's true. It can't go down. It does go down every once in a while. But also, look at these values. This one says that the height is, well, it says that the time is -20 and the height is like -20 or something like that. So that doesn't work out because it's not rational. Like you can't have negative time or negative height. So B is not it. And then what about C? That's got to be it because it's the only one left. But why? Why? Positive numbers, so that's what we need, and it is increasing, so the height of a plant would increase. So C is the only graph that's rational. So C is the correct answer. And then on example 7, okay, here's where you need a straight edge. Let me pause here real quick. Okay, so with your straight edge, here's what you want to do. We're going to create a trend line. So a trend line has about half of the points in the relationship above it and about half of them below it. Please do not feel like you have to connect points, okay? You can, like if the points are on the trend line, it's okay, but they don't have to be, okay? So when you draw your trend line on your paper, you want to make it go off the graph and all the way through, so it should look kind of like this. Okay, so everybody draw a trend line on their graph. I'm going to walk around and see everybody's trend line so I can make sure that you're doing it the right way. Okay, so we drew our trend line. Let's read up here now. It says the scatter plot shows a relationship between the total amount of money collected and the total number of rolls of wrapping paper sold as a school fundraiser. Based on the relationship, predict how much money will be collected when 175 rolls have been sold. Draw a trend line and use it to make a prediction. So we drew our trend line, right? Here's the trend line that we drew. And it says predict how much money you make if you sell 175 rolls. So here's 175, right? Everybody find 175 on your graph. Here's 175. So I'm looking right here, okay? Because that whole line represents 175. So what I'm going to do is travel up that line to where my trend line crosses, right? There's where my trend line crosses. So approximately how much money will I make when I sell 175 rolls? So about $1,200. Now, depending on how you drew your line, it may be a little bit more or a little bit less. Like I think last period when I did it, I got $1,150. Okay, but I'll accept a certain range. Like when we have quizzes and stuff, I'll probably make it multiple choice so that there's only one rational answer for you to pick from. Okay, so here I would say about $1,200 is how much money you would have made. And that's it, right? That's all the examples. Okay, homework tonight is 4-9. You need enough graph paper to do 2 graphs. So if you don't have your own graph paper, make sure that you get some from me before you leave.